Amit Sharma, Senior Researcher, and Emre Kiciman, Senior Principal Researcher, both at Microsoft Research. Welcome to the Data Exchange Podcast.
Thank you, Ben. It's great to be here.
And so you're here today because we're going to talk about causal inference as a topic, but mainly because you folks have a library, an open source library that I think our listeners will be interested in trying. But before we get into your library, first off, at a high level, I guess, because most people probably have read about causal inference, but also a lot of people have never actually thought about it deeply. So what is causal inference at a high level? So let me give that question to Amit, and then I have a related question for Amra.
Yeah, so how I've started thinking about it is that causal inference is the science of making better decisions. So whenever you have a decision, for example, whether the vaccine works or not, or what kind of economic policy a country should adopt, these have been historical decisions where causality has traditionally been applied. But today, what we are seeing is with AI systems being deployed in many different settings, the same kinds of questions are also coming up for those systems. Because let's say when you are recommending certain jobs to people, or when you're recommending financial decisions, we want to make sure that those decisions also have the right impact on the users and the platform at large. And then there are also questions about fairness and robustness of systems. And so causal inference is the sort of sibling of prediction in terms of scientific inquiry. So one kind of scientific question is, I see a system evolving in some way. Can I predict what will be the next event in this system, right? That's prediction. And causality comes in when you want to ask, I see the system proceeding in a way. I now want to change the system. I want to make the system better. What should I do so that my intended action actually also has the right consequence on the system?
So Amra, so does this requires somewhat of a different mindset, right? So in other words, most data scientists probably know statistical modeling. A lot of them know machine learning. Well, machine learning, you have either most of the time you have supervised learning, so I've labeled data, and then basically you're done. You fit a model. So this requires somewhat of a different mindset, right? So what sets it apart from some of these more traditional approaches that I mentioned?
Yeah, so I think you're right. I think it does require a different mindset, Ben, and it's for a simple reason. One is the conventional machine learning methods. They look for patterns in data. You give a machine learning algorithm a pile of data, and it sifts through and tries to find all the patterns, all the associations, and it's going to find some patterns. They might be spurious patterns, they might be real patterns, but it's definitely going to find some patterns. And you can test just using the data that you've been given. You can test whether or not the patterns you're finding are, robust or reliable within the context of that data set. You can hold out part of it, right? And then see if the patterns you're finding here continue to be valid in your holdout data set. And so the whole process of machine learning is really defined by what you see in the data. But in causality, that's not necessary. In causal inference, causal machine learning, causal learning in general, that's not necessarily the case. You have a pile of data that was generated through some mechanism, but your observation of that system and kind of the mechanism's behavior is never really complete. There's always something you didn't see, some version of the system that might have behaved a little bit differently. That's going to mean that if you only look at the data, the patterns you find may or may not be the ones that are causal. So you have to find other ways of constraining your model to focus on the causal methods. That's what makes causal learning unique, is that fact that you have to bring in some external knowledge, some structure, something to guide the machine learning model.
So Amra, some listeners will say, what about the unreasonable effectiveness of data? Remember back in the day, let's just
we have big data. The device of theory, is this the end of theory, right? Was one of the major articles there. What it comes down to is we found out since then that the data is good as long as that all data is biased. And if that bias represents the problem you're trying to solve, that's great, right? If you can collect enough data that covers all of the different situations you will ever see in real life, then that's great. But there are certain kinds of applications where that's really hard. Obviously, there's the ethical challenges with certain kinds of experiments. There's
as they're finding out with edge cases in computer vision and self-driving cars, right? So.
Yes. Yeah. And one of the particularly challenging places is decision-making applications. This is the case where conventional machine learning depends on the IID assumption that your data that you're training on looks like what you're going to be deploying on. But when you make a decision with an ML model that's going to affect the data distribution that you're observing in the real world, your application itself is causing you to break that IID assumption. That's one of the cases, for example, where the data is not going to be enough. You need to do more to model the consequences of your decisions and your actions to compensate for that interventional distribution shift.
So before we get into your library, I'll put you on the spot. So imagine I invited you to give a keynote at a conference I'm chairing. And in the course of your keynote, you have 2 slides. Two slides to sell causal inference or causal learning to the audience. Those 2 slides will have 2, I guess, use cases in production that involve causal inferences. So let's start with Amit. What would be in your 2 slides to get people excited? To get people excited about causal inference. It doesn't have, by the way, it doesn't have to be confined to Microsoft use cases. It could be just anything.
Yeah. So I think the first use case I'll put is a very practical use case, which is of finding out why a certain system has failed or is doing poorly. This is a common problem you can imagine from sort of systems that are tracking revenue or even systems that are tracking subscriptions, right? So imagine you're a subscription company, your subscription suddenly drops. You want to know why. And today with causal machine learning and causal tools, we are able to address this question much more systematically than the default answer of let's just build a predictive model to see which is the most predictive feature for the drop, right? And so what you can do by that is actually make better decisions and also explain to others on why those decisions may be more robust. That would be my first. And the second one I would say is my sort of favorite cow-camel example. Anytime you're building a natural language processing system or a computer vision system, the common example is that suppose you have a data set where all the cows are on green grass and all the camels are in brown desert, right? You wouldn't know that and you would train your system. And actually it has been shown that even modern machine learning algorithms often would just learn that grass represents cow. And it's much easier to predict a cow if you just learn the green grass as the background. So this is the truth for state-of-the-art systems today. And if you don't know what are the cows and camels in your data set, you're bound to kind of make similar mistakes when at deployment time, if a cow comes on a beach or on a desert, you would still think it's a camel, right? So those would be my 2.
All right, Amra, what are in your 2 slides?
My 2 slides, I think the 2 use cases I'd focus on would be, like from a technical perspective, would be generalizability and robustness. And for that one, I would point out a couple of examples where we have hands-on experience building machine learning models that are more robust to unseen distributions, dynamic shifts in the context of advertising systems. We've seen people talk about modeling financial systems. And we've seen this happen, generalizability and robustness help in the kinds of computer vision systems that Amit has just talked about.
So in your examples, I assume there was an incumbent model. And so the causal model was outperformed it enough to justify swapping?
Yes. So I'll mention that one that we published on. So we have a lot of partnerships inside Microsoft where we work with different product teams, from Azure to advertising. This is one in our advertising platform where our ad team runs a simulator to see how their deployed policy is going to behave in the real world before they actually put it out there. So they replay logs, and there's a model in there that they depend on behaving well, even though they're changing the underlying system. So that's that interventional distribution shift that I mentioned. Now, they were using conventional machine learning models to build that particular model, and it worked well as long as their changes to the system were small. But when they had a larger change to the system, it would have a very high error rate, compared to actually when they deployed the system to the real world, right? So they get to see afterwards whether their predictions were, roughly correct. And so we came in with some structural knowledge about how they were gathering their data. We added a little bit of extra randomized data and used some of the causal methods that we've been developing to build more robust models. And now when they make these bigger shifts, they get significantly reduced error rates as compared to those conventional methods.
By the way, before this podcast, I forgot to mention to you guys that I did some data mining, and I found that in the major machine learning conferences, there's a steady growth in papers that mention causal inference.
Yeah.
Now up to about 4% of papers, which are close to 1 in 20. Pretty cool. Okay, so now we go to DoWhy, your open source project. And I think it's pretty clear why you guys created DoWhy, because I've been kind of interested in this space for a while, and there's just no good tools for someone who doesn't want to who just actually wants to use causal inference, right? So, Amit, I'll turn to you. So, what were some of the key design decisions that you folks made? So I guess you can answer it by saying, in your folks' mind, what are the major components of a practical causal inference library?
Okay. Yeah. So I think the reason we started it was our own sort of journey in learning about causal inference. And we realized that it's a deeply technical field, a lot of contributions from statistics and other fields. And we as computer scientists were kind of lost at the beginning, just trying to understand this vast literature. And at the same time, there's Uriah Pearl and his amazing work on graph theory and graphical causal inference, right? So we both sort of went through it. We took a lot of time to really understand what's going on. And we thought it may be good if we can spare others that effort and just create simple, clean API for you to start learning just by doing, right? Rather than having to read these sort of very complicated textbooks on causality. So that was the motivation that went in. And I think the design decisions that came immediately was what Emre was just talking about, right? We cannot have a simple API where you input the data and we give you the causal estimate, right? That's not going to work. So what can we do? So we thought, let's bring out the 4 steps that we believe are the sort of fundamental steps of causal inference. And actually all researchers do that anyways as best practice. So we thought, why not do it in a proper API so that when people start using causal inference, they have a clear list of steps to follow to get their estimate. And that was the design decision we took. We said the first step has to be modeling your system, which is you make a causal graph about how different parts of the system are interacting with each other.
So let me ask you this: who was the intended user? What personas were you targeting?
Yeah, so data scientists especially, but also students and sort of people who would want to learn about
non-experts.
Yes.
Yeah, non-causal experts for sure.
Yeah, there's an, by the way, to our listeners, there's an accompanying paper where they really sketch out the components of the system that I will also link to in the episode notes. But um, so what is the state of the library right now? Has it lived up to what you folks want to use yourself? Is this the tool is this the tool you set out to build is what we have today?
Yes, and I think we're doing more. So yes and no. So in terms of estimating the effect of any intervention, I think we've superseded our own expectations. When we started, we were thinking of it mostly as something that we're doing to sort of help ourselves as well. And we thought maybe there'll be a couple of users. But actually, like in the past few years, we've had so much adoption for this core use case of estimating causal effect. We keep hearing from students who are using it for their projects. We hear from companies who are deploying it in their sort of workflow. And then we also have researchers who are using it in their classes and so on. So I think from one task, which was causal effect estimation, meaning you have one action and one outcome, you want to know how much it's going to impact. We've done pretty well, I think. What we are focusing on now is expanding that to include all the range of causal tasks that people are interested in. So think about prediction, right? We talked about generalization and robustness. We are planning to add that to DoWhy as well, so that you can use the same principles to also build robust machine learning models. We're also thinking of attribution, counterfactual estimation. So I think what we are hoping now is that given the success that DoWhy as a library has had for causal effect inference, can we translate that to other tasks like prediction and counterfactual estimation? And also, I want to mention that it's not just us. I think what has happened is that there's a community of developers which has organically evolved. And that's, I think, the most heartening part of it, that a lot of people are coming in and saying, this is cool, I want to contribute more and make it more powerful.
So Amra, to make this concrete for our listeners, take us through, so what is the workflow for DoWhy? So like we discussed earlier, in traditional machine learning, I start with data, right? So first I got to collect data, label it, clean it, and so on and so forth, right? And nowadays, actually, that's the job of the data scientist, because now you have auto ML. so all you have to do is really focus on the data step, right? So what is the equivalent workflow for DoWhy? What do I focus on, and what are the things I have to do?
Four steps to do, and going through each of these four steps was really why we made DoWhy. This was something that a lot of experts were skipping over. They were doing essentially these four steps separately in their head, right? And then we wanted to make it explicit for the people who didn't already know what to do for each of these steps. The first step is specifying your assumptions in the form of a causal graph. So you have all the features that are represented in your data, and as much as you know, we want you to kind of draw out your assumptions about what might be affecting what.
So stop there. So do you guys have a UX where I can do kind of the Judea Pearl kind of graphs?
It's the Judea Pearl kind of graph, but we do have, you do have to write it out in like a .x format or something. Right. The user interface for specifying it, that's something that we would love to, see someone provide as a contribution.
At some point,
right?
That would be the dream, right?
Yes, we will render it for you. We'll draw it out for you once you give it to us, right, as part of the output. But
one thing I quickly want to mention is there's an excellent tool called Dagity that does allow you to draw your graphs, and DoWhy allows you to just export the graph from Dagity. So you can use that as well.
All right. So then step two is?
Step two then is identification. You tell us what you want to estimate. So I want to estimate the effect of, this feature X on some output Y. And we take a look at the causal graph that you have, and we tell you whether we can disentangle all of the different interfaces, what variables you condition on, etc., to come up with a strategy, an identification strategy, a causal estimate that's going to give you this particular, effect of X on Y.
So Amra, so this is kind of different in a sense from this era in machine learning with deep learning, where it's such a black box, right? So here, what you're saying is people really have to specify, really have some sort of domain knowledge up front. And then they have to carefully kind of do these estimates. So do you do this kind of estimations one at a time? Like, okay, so here's this variable. Tell me the effect on the outcome. Here's another variable. So what about kind of linear combinations or whatever, right? So
this is where we're starting to get into some of the more complicated causal inference, the causal tasks. The first task that DoWhy supports is simply effect inference. If I change a particular variable, what's going to be the effect on some given output? Right? And that's what causal effect inference is. What's the causal effect of changing this with everything else staying the same? Right. Now, we do ask the user in step one to give us their domain knowledge in the form of a causal graph. The identification step is actually algorithmic. You tell us what you want to estimate, and we'll figure out, all the conditioning, everything using standard algorithms like the ID algorithm.
So in practice, do people write scripts to say, let's say I have 50 of my causal graph is complicated. I can write a script to just walk through all of the
yes. So if you care about care about multiple drivers, then that's what you would do. You just go through and iterate through each of the things that you want to change, and calculate the effect of each of those on your output reward.
Okay, so then I get the causal effect. Then what? What's the next step?
Now the third step is the actual statistical estimation. So that second step tells us what to estimate, like what is the formula we want to estimate. The third step then actually goes and estimates it. So it goes and does all the math and statistics behind the scenes.
And so you folks have enough guardrails for people who are not experts to suggest what estimation algorithm to use, and there's some defaults in place that.
Yes, and DoWhy itself natively implements a couple of simple estimators, and then we call out to a couple of sister libraries like the econML library for the more complicated double ML and other estimation strategies.
I see. And then the final step, I assume, is some sort of robustness and validation.
That's exactly right. Yeah. The final step then is, we go back and double check your assumptions. We see whether your causal graph makes sense with given the data. We go through and run sensitivity analyses, whether you might be missing, say, some unobserved confounder that wasn't included in your data, and then give you back these test results to give you some confidence in your final answer.
So the big thing here is that in the past, you might have had to piece together several things to do these 4 steps, right?
Yes. Yeah, and these weren't all out there. So we run a very simple test, a placebo test, right? We will replace your treatment, the thing that you're intervening on, we'll randomize it. And once you randomize it, we expect that its effect is going to be 0, right? We're just inserting in a random value. It should not have any association at all with your output. But sometimes there's a mistake somewhere, and you get a non-zero value. This is a standard test that, say, econometricians, for example, will run as a matter of course. But they don't necessarily talk about it in their papers, right? You have to go and talk to them on the side to say, hey, what test you run? So that type of thing is now embedded in this library.
But my point is, this is other causal inference libraries might have tackled only a limited part of this pipeline, right?
Yes. So that was what we saw is other libraries focused really on the statistical estimation. And in some sense, that makes sense. That's the hard part to code, right? Yeah. The other pieces are easy to code if you know what to do, right? But that doesn't help the data scientist who's not already familiar with causal inference.
So, Amit, as you look ahead, so the roadmap will focus on what part of this 4-step process?
Yeah, so I think we are pretty happy with the estimation step for causal effect inference. But the actually 3 places we want to investigate more is one in the expressing your assumptions. So to what extent can we use causal discovery algorithms, which take a data set and build a candidate graph for it? It's always not correct because yes. So that will definitely make it much easier for people to start with causal inference. And then of course we want to also encourage people to edit the graph based on their domain knowledge, because those algorithms are not always correct. The second thing we want to focus on is on refutation, so that we get the equivalent of cross-validation for causal inference. So right now the issue is that in machine learning, we're able to make so much progress because cross-validation is kind of a check. It's a guardrail from deploying bad models, right? So right now, we want to do more research in these robustness and sensitivity checks so that we can at least reach a stage where you can do model selection, right? We may not be able to tell you whether this model is correct or the other one, but at least if you have 2 models, we can tell you which one is more likely to be correct. And the third would be on prediction, as we had mentioned, right? We want to take the recent work that's happened in causal machine learning to build models that generalize outside the domains they are trained on, and have that as a first level functionality in DoWhy itself. So now you can actually also build prediction models that are robust to different kinds of shifts.
By the way, Amra, you mentioned this earlier. One of the challenges in this field is it's kind of like the old statistics and machine learning back in the day, in that they probably were doing similar things, but they never talked to each other. But this field is probably even more pronounced because now you have statisticians, people in the biostatistics, all sorts of fields, probably duplicating work. So the nice thing about what you folks are doing is, as a user of this library, you capture a lot of what they're doing, and I can just kind of take advantage of it in this one library.
Yes, and I mean, to the degree that people are continuing to advance these methods in their respective fields, we hope that prominent libraries like ours can be a place where people come together. And the community is also coming together more broadly. We're seeing more, at least on the academic side, more conferences that are trying to draw in researchers who are doing work, whether it's in, like you said, biostats, stats, econometrics.
Do they even use the same terms?
Not always.
Yeah. By the way, I was expecting Amit to say, so when I said, what are you going to focus on? And this is always a pet peeve of mine for open source project. No one says documentation, right? So isn't that kind of key for an open source project? Documentation, tutorials. So how would you guys rate your documentation and tutorials for beginners at this point?
I think it's reasonably good. We have quite a few kind of starter notebooks, and
I will test that. I will test that tomorrow.
Let us know if you find something missing. Do let us know. Yeah.
So this is an open source project. So I assume you guys are committed to really kind of maintaining it and getting it better and polishing it. So to that end, what metrics are you guys tracking? Is it GitHub stars? How do you guys measure the progress of the project at this point?
I think there's 3 that I'm interested in. One is the community of contributors.
Yeah, which has grown, right?
It has grown. I think we're we've got I think about 80 or 90 contributors now.
And how many are outside?
Sorry, 50. Sorry, I was reading off the wrong line.
How many are outside of Microsoft, if you were to guess?
But 2/3 on it. What do you think?
I would say more than probably 80% are outside Microsoft.
Oh, nice. That's nice. Yeah. Okay, it's a number of contributors. What else?
The second one is I don't know if Amit looks at this, but I look at the number of pip downloads, especially like daily downloads, and to get a sense of how many active users there are.
You can game that because you're at Microsoft. You just ask Microsoft to add it to one of their key Python libraries, and
we haven't though. So for now, it's still reasonable.
That's a requirement.
Yeah, and then the last one is a bit more qualitative. I'm really interested in hearing about the stories where someone comes to us with either a success story or failure, kind of about the kind of problems and kind of the importance of the problems that they're trying to tackle with this library, to get a sense of whether it's being useful.
I'm surprised you guys don't use you don't track the page views, web analytics, what part of the documentation people are reading, that kind of thing.
It doesn't make my top 3 though.
Yeah.
Like I like the stories where someone says we're using it, as an integral part of our platform,
I get,
right? Or that type of thing.
I get that, but just traffic to your docs would be a great metric too, right? So if that's growing.
Yeah, that's true.
So to that end, to Amra's last metric there, which is the case studies. So how many logos can you put on the DoWhy docs now of people using DoWhy, I guess, in production? If you were to guess, so how many would that be?
Yeah, I would say at least 10 that we know of.
Pretty good. Yeah, that's
through emails.
Yeah. It's I get a sense that there's a lot that we're not aware of. Many of the stories that we've heard of are mature enough that it makes me wonder what's going on that people aren't telling us about. So if your listeners know of fun use cases, just, I'd love to chat. I'm very interested in kind of learning about where it's useful or where it hasn't been.
By the way, you folks have day jobs as researchers at Microsoft Research, but if you did not, you would probably have some kind of Slack channel, right? So where users can go and then Amre, this is how you find out who's using. If you
we have a Discord channel.
Okay, good.
Yeah. So we do hear from people there.
Yeah.
And just to answer your question, Ben, about metrics, right? So I think initially, yes, we have been tracking downloads, etc. But right now our focus is on case studies, as Emre mentioned, right?
Yeah.
Can we showcase through DoWhy what is the power of causal inference? Where are people using it? And here are some starter notebooks on maybe simulated data to understand what all people can achieve with this technology. So that's the sort of thing we want to move towards, to more realistic examples.
So do you guys have a specific plan? Let's say you gather 10 to 15 use cases. So what's your plan in order to communicate that? Are you going to start writing blog posts? So DoWhy will have, you guys should consider having like a dowhy.org website where you basically organize a lot of these things, right?
Yeah, that's a good idea. So I think we're exploring 3 ways. So one is just writing good notebooks.
Yeah.
I think we're still very committed to the developer ecosystem, so that notebooks are the main place that you need to go if you want to understand this. Separately, we're also thinking of a better developer documentation. So not just for users, but also for developers to understand how it works. And the third thing, it is more academic. So Emre and I also are writing a book on causal inference and its applications in machine learning. And that book is academic, but the exercises in the book are using DoWhy. So we are hoping that people who are also just learning it would also have a nice interface with the concepts and then the code in DoWhy.
So, what's the state of causal inference in academia as far as you go to any university, some of the most popular classes are data science and machine learning, right? So are there
Yeah.
equivalent accessible classes for causal techniques?
I think it's getting there, but it's not where we want it to be yet.
Yeah.
And like you said, you mentioned earlier the way that causal methods are being researched and studied across so many fields. I think we see that in academia, in the education part of academia as well. We see some people teach from an econometric perspective, others are focused on the statistics or the medical side of things. And so I think that split ends up affecting the accessibility.
By the way, Amit touched on this when at the start of this conversation, but there's actually such a natural tie-in to what people now refer to as responsible AI, right? So it's
Yeah.
basically it really is a powerful technique for aspects of responsible AI, which is this umbrella term for collecting a bunch of risks associated with AI. So fairness, as Amit pointed out, but also
Yeah.
even explainability, interpretability.
Mhm.
So to what extent is the broader ML community taking advantage of some of these techniques for this problems?
They're
Yeah. I
starting
think
to,
that's
yeah.
yeah. Oh
Go
yeah.
ahead, Amit, yeah.
Yeah, they're starting to, and I think there's a lot of interest, especially in explainability community, to use causal methods to understand what models are doing. And this is not just for decision models, like let's say loan decisions, but also for complex models like BERT. We built BERT, but it's so complicated that you often have to use the same kind of causal techniques that you would use to understand a real world system to understand a machine learning model also. So people are starting to do the same kinds of experiments of, if I change this layer, how will the output change, to actually learn more about what BERT itself is learning. So yeah, I think in explainability and to some extent fairness as well, there's a stream of research papers which is talking about causality as one of the backbones for doing that.
I think it's worth mentioning kind of at a high level why this connection exists as well. And it's basically the causal methods are about making sure that your machine learning model is grounded in specific mechanistic kind of patterns that you observe in your data. It lets you figure out which patterns are real and not real. And once you start to have a language for manipulating or describing or kind of scaffolding those patterns, that then also gives you the tools to remove the patterns that you don't want to have in there, say, for example, from a fairness perspective, or to look and explain what those patterns might be about. And that's, I think, where this connection comes in. Causality is not going to solve all aspects of responsible AI, but the fact that it gives you that ability to look at to give some structure to what the model might be doing internally and control over it, I think is a powerful part of it.
Which by the way has huge impact for users, because users trust the model more. For managers and decision makers, for same thing, and even regulators, right?
Yeah.
So what's the if you folks were to predict, and I know you are not in the business of predicting, but so if you look at data scientists today, so what are some of the things they do? So they do some reporting, right? So they do they're responsible for generating some ad hoc reports, maybe. They do some modeling, machine learning. For those fortunate enough to work in companies with great experimentation platforms, they run experiments. So is causal reasoning going to be another one, an added capability of data teams I hope so. But what's the timeline? I guess it depends on tools like DoWhy, right? So the timeline really depends on whether or not
Yeah.
the teams can do it themselves, right?
I think it's starting now. You're starting to see at least the teams that are operating a bit more at the state of the art picking up these tools. I think that it has quite a ways to go yet, though. I think that rather we have a lot of runway to continue to improve these methods, I should say it that way. But I think that, yeah, I think that causal methods will continue to become more and more important in, I mean, speaking in round numbers, I think 5, 10 years from now, if anyone isn't using these tools in some of these, simple ways, I'd be surprised.
So do you folks still find yourself having to do what we did at the start of this podcast, which is just to explain what it is? There's still a lot of educating that needs to be done.
Mm-hmm.
So
Yes, yeah.
And this is generally true even for the data scientists you talk to. You probably still have to educate, right? So let alone non-experts, right? So
yeah, I think the two challenges to the adoption, one is education, as you mentioned, which is to communicate why it's important, right? Rather than just having a prediction model. And the second is also, why is it hard? Because when we present the solution, you have to think about the domain assumptions. You have to think about robustness checks. That just seems like much harder process. And so I think one thing I hope will happen in the next 5 years is that research will catch up and make some of these processes more simpler for the end user, right? And I think that may also drive up the adoption. Often what we are seeing is people are interested once they learn it, but then the steps to take often are a little bit prohibitive in the daily scheme of things. So that's also, I predict, will happen.
So you hinted a little bit, Amit, earlier about kind of automating even the step one a little bit. And in my head, actually, Amra, feel free to push back, but maybe this is a bit sci-fi. But in my head, I think the ideal end state would be some kind of no-code tool where business analysts who are close to the line of business can do some of these things themselves. Because they have the domain knowledge, they know the data, they know the business problem, right? So it's just a no-code tool on Azure or some other cloud service, and then you go end to end. How far away are we from that, Amra?
Not that far away. I mean, if if we can get past the kind of education aspect of what is causality, what is this graph, what does this graph mean, having someone who doesn't know how to code draw out that graph, someone who understands the data but doesn't know how to code, draw out that graph, then point and click about what they wanted to infer, and then run through the system. I think that's not too far away.
And with that, thank you, Amit and Amra. This has been great, and I will make sure to link to the DoWhy site, which has all of the good stuff. And I hope to have you guys back here in a year or so to check in on the state of the project.
Okay.
That
Thank you,
great.
Ben. It was a pleasure.